Thank you everyone for coming to our session. Hope you enjoyed some classic French house while we're here in French-speaking Brussels. We're your hosts for this session. My name is Joe Clark. You may have seen me here yesterday. I am not doing any singing today, I'm sorry. I've been at Atlassian for 15 years and I'm the product manager on the Forge team. And this is my fourth Atlas camp.
Hello, I'm Ben. I'm the engineering manager for Forge Compute. I've been at Atlassian for about 3.5 years now. And I like long walks on the beach. So I'll pass it back to Joe.
Make a pretty good pina colada too, actually, Ben. I'll make one for you. So as Ben mentioned, he's the engineering manager for Forge Compute. I'm the product manager. We're responsible for the computing environment for Forge. So that's primarily the Forge Functions capability that runs your code on AWS Lambda. We like to think of our team as the engine that powers Forge, and just like a bullet train, we want the experience of running apps to be fast, smooth, reliable, and efficient. We've really embraced this analogy internally with our team. We actually have a team motto that is toot toot Forge Compute. This is Ben's team jumper. And actually, as a little treat for the team back home now, what I'm going to do is get Ben to record a video. And I'm going to say 1, 2, 3, and I want you all to say toot toot Forge Compute. And if you do like a little hand gesture, like a toot toot, that would be great as well. Okay, ready? 1, 2, 3. Toot toot Forge Compute. Yes, thank you.
Thank you.
So our compute engine is a powerful little thing. It's been growing over the last 4 years and still going strong and growing even further. Adoption of Forge has obviously been growing a lot over the last few years. And not only are we getting more apps on the platform, but those apps themselves are more complex, more powerful, and consuming more of our platform. So here's a few big numbers to put things into perspective where we're standing today with Forge. The first one is 195,000. Now, who would like to take a guess what 195,000 is measuring when it comes to Forge? Installations? Oh, no, not quite. It's close. This is the total number of Forge apps that are currently in the Forge app database. So it's obviously very high because this includes, customers building apps, Atlassians building apps, people doing ship-its and hack-its, people who have done the Hello World tutorial and then never deleted the app. And then also, the 1,000 plus apps on the marketplace. But even those apps that are the Hello Worlds, right, they're still sitting in our platform. We're still deploying Lambdas. They're still sitting there when we're managing them and supporting them. And the next number is 11,000. Who would like to guess what 11,000 is? I thought we were friends, Daniel. No comment on that answer. The correct answer, this is the average daily runtime hours consumed on Forge on a weekday. So in a 24-hour period, we've got 11,000 hours of Lambda being consumed, roughly Monday to Friday. I must quickly declare for the recording, these facts have not been formally approved by the Atlassian legal team, so please take these with a grain of salt. I measured them accurately, but I officially am not allowed to say that these are the true numbers. We've got lots to cover in our session. We're going to take a hands-on look at the new runtime in Forge, which has been our team's primary focus over the last year or so. I've also got a demo of our new long-running functions feature that we launched last month, and an overview of some other goodies that we've been working on. And finally, I'm really excited to share some of the early thinking we've put together regarding where we want to take Forge Compute in the future. So first, I'm going to hand over to Ben, who's going to walk us through the Node.js runtime.
Thanks very much, Joe. Hands up, who's using the Node.js runtime right now? Nice, ooh, well done. All right, so Forge new Node.js runtime is faster, more reliable, and more compatible. Let's get into the detail. So on the screen, you have a diagram of the new Node.js runtime. So what we do is take your app code when you do a Forge deploy. We put that inside an AWS Lambda. We have a very thin wrapper around that allows to take your logs, take your metrics, and then allow egress out. It also deals with the fact when you call as app, request Jira and stuff, it handles that for you as well. Then we can move on to the Forge outbound proxy. You can see the white box below. That does two key things. Handles all egress coming out of your Lambda. It makes sure that your manifest lines up what you're actually requesting to make sure we block anything that hasn't actually been requested. And second, it also handles putting in the short-lived tokens to go to Atlassian APIs, or potentially external auth token off to, say, Google or Microsoft. The key benefits are a lot more compatibility, which I'll show you in a demo shortly. With the Node.js ecosystem, so the sandbox runtime, that had a lot of problems where you couldn't actually just run npm packages if you wanted. We also noticed on average a 35 to 45% increase in performance, migrating from the legacy runtime to the Node.js runtime. And it's getting faster and faster as we get on later and later versions of Node. Last point, it's a simple invocation semantic, so no more snapshotting. And you'll see the benefits of that during tunnels or deployments. Now, bear with me while I switch over to do a live demo.
We're trying to bring back a bit of old Atlas camp by doing a live demo. So a little bit clunky, but, you know, gotta take the plunge. Otherwise, how do you know it's real?
Next display.
Let's take it.
I'm trying, man. I'm trying. It's not working.
Oh, really? There you go.
Hey, are we in?
Yep.
Perfect. Thank you very much. All right, so I'll run you through a quick demo of how you take a legacy sandbox app and how you migrate it to Node.js. So what I'm showing on the screen is the Sydney food menu. Potentially getting the grilled chicken thigh today if you're down on Monday. So what we did was we create a Slack app to try and get this menu into your phone. So basically you can wake up in the morning, check your phone. I don't like that food. I'm staying in bed. Cool. So how does this work? Very simply, you got a Slack app. You have Forge as the brain and the processor, and we have Confluence where it stores the menu. We take an incoming webhook, which calls a Forge web trigger. We process that data, and then we call out to Confluence to actually get the actual menu, come back, format it, and I'll show you a quick example of what it looks like. So we format it in a nice and easy consumable method. Very simple. There you are. So let's jump into the code. So this is a...
Is the code font size okay? Too low.
Too dark. We'll leave it, sorry.
Okay. There'll be a recording. It looks really good on this screen. I can do some interpretive dance to demonstrate the modules that you're talking about.
Yes.
No. I'll read it out for you. So what I'm showing you is the first trigger. It's a product event. We're looking at the updated page event. So pretty much any time the team come in and update the menu, you can find it when you get the latest chocolate muffins or so forth. So send them out. Second is a web trigger, the key part that communicates from Slack to Forge. It's a standard web trigger. And I'll go into a bit more detail about the pain we went through with that. Then you got a scheduled trigger, which will make sure you get the menu sent to you at 8 a.m. every day. Now maybe you can't see here, but on the difficult with the legacy runtime is the fact we couldn't use the Slack Bolt client. We actually had to hand roll a lot of the methods to Slack API. So do a manual fetch, handle the request, response, and any errors that occurred. So not too difficult, but just a lot more code than we thought we had to write initially when we wrote this. Now, the difficult part was when you call from Slack that calls our Forge web trigger, you have to roll your own auth, and we use Slack's method to do that, which is a proprietary method, which takes a few keys and compares them and does some math. This would be super easy if we can use the npm package, but we couldn't, so we had to hand roll quite a few things. We couldn't use some of the key packages that we needed, like crypto. So example in here, we just had to copy and paste code out of the Slack Bolt.js, which is not ideal, and then also copy and paste some other npm packages directly into the Forge platform. Cool, let's jump to the future where we've migrated to the new runtime, Node.js. In the package JSON, you'll notice that we're now using the Slack Bolt npm package here, which then will save us a lot of effort. So by doing that, the verify request TS I just walked you through is now deleted, gone. So 93 lines of code that we had to build before no longer needed. And then also the Slack TS, which we had to hand roll quite a few things, that's also reduced down to 60 lines, remove 60 lines of code. So a win. All right, let's just do a bit of fun. So I've got the same app, one on Sandbox, one on the Node runtime. Who do you think will be the quickest tunneling Anyone for sandbox? Anyone for no runtime? Okay, let's give it a go.
Objection, leading the witness.
So we're doing Forge Tunnel on sandbox, Forge Tunnel on the Node runtime. Now, one benefit of the Node runtime is you don't need Docker anymore. So that is not needed anymore. It just runs on vanilla Node.js, which is awesome. So as you see on the left-hand side, Docker image is building. On the right-hand side, the internet's probably failing me.
Yeah, we might need to cut this short if the internet is being crappy.
Yeah.
Unless you can swap monitors faster for the second demo.
Yeah, it's not working. It's all good. Demo gods have got me. But yeah.
Look, in our practice run, the Node.js runtime we were tunneling in it while Docker was still booting up.
Yeah. All right, let's get back to the demo. Cool. Hello. Awesome. So why are we running that demo? One key thing is the legacy runtime is being deprecated. We announced that over 5 months ago. So there's a few key dates you need to be aware of if you're still running on a legacy runtime. So from the 14th of Feb, we are blocking invocations in development. So that's a first indicator that yes, this is coming, and it's coming next few weeks. Second key date is the 28th of Feb. Deployments will be blocked in staging and production. That'll give you, and 1 month after that, we are turning off all invocations in production. Now we have a guide for you to follow, upgrading from legacy runtime. Please jump onto the Atlassian.com runtime version upgrade. And if you have any unique situations where you can't meet those dates, come talk to Joe and I, and we can have talk through your unique case.
I know that QR code's right at the bottom. It's hard to see. So there's another slide at the end that's got the links. So don't worry if you missed it.
Back to you, Joe.
Thank you, Ben. All right, long-running functions. Earlier this year, last week, we solved long-running functions on Forge. We were working hard to address what I would say is one of the biggest limitations in the Forge runtime today, which is the maximum runtime limit. So if you've ever tried to do anything complex in a backend function on Forge, you would be very well aware that the maximum runtime limit of a Forge function is 55 seconds or 25, depending how you invoke it. And less than 1 minute is not really a lot of time to do anything complex or anything that requires a sequence of operations to happen. So this really limited what was possible to build on Forge. It kind of basically prevented certain use cases. And if you were sufficiently motivated, you could do it, but you had to write so much plumbing code to handle breaking up the complex task into these like tiny convoluted invocations. So some of the examples that we saw people struggling with are things like accounting for API response times, right? So if you make a fetch call out to something on the internet or even a Atlassian REST API, typically, calling an HTTP request, 60-second timeout is the default, right? How can you wait for a 60-second timeout in a 55-second function? You can't. So you have to handle timeouts and retries. You don't even actually get to see the timeout because the function just dies. Then we also have things like rate limits and retries. So you try and call a complex batch task in Jira. That might take who knows how long. It depends how busy the instance is. It'll come back and say, yes, you did a batch update. These issues were updated. These issues weren't updated. You got to extract that, figure out what you need to retry. Do I have enough time to enqueue it in this invocation? No, I've got to schedule another invocation to do that retry of those ones that failed. And then, as I mentioned, keeping track of how much time is left. There's actually no capability to do that in Forge today. So if this is important to you, you are hand-rolling your own timer or stopwatch. There were some really creative workarounds to these limitations. Like they say, design is the beauty of constraints. Well, I applaud some of these workarounds. My favorite one was working around the cyclic invocation limit in Forge. So when you do async functions, you're able to recursively enqueue a maximum of 1,000 async functions before we say, please stop, what are you doing? But if on your 999th invocation, you call a web trigger, and that web trigger calls an async function, you have got yourself another 1,000 invocations. And I don't feel bad kind of sharing that with you because there's actually a tutorial on on developer.atlassian.com that shows you how to do that. Necessity is the mother of invention. But Hopefully, we've made that a lot easier now. So async functions can now have a maximum runtime of up to 15 minutes. So you still have to do that work of breaking down your complex task into kind of small chunks, but 15 minutes is a lot more to work with than 55 seconds. And I do have a little demo to show you it working. It's just recorded because I couldn't really think of a way to make a 15-minute demo be engaging. So this is a video that kind of like speeds up time so you can see it happen. So here's an app I've built. It's got a global page in Jira that I'm going to use to kick things off. There's a queue consumer that's going to like be triggered by the front end, and then that queue consumer is backed by a function that has a timeout seconds configured of 900. So that function can run for up to 15 minutes. I've got my local tunnel running, and I'm going to open up my app and kick off. It's going to invoke a resolver that enqueues the async function. And this async function is going to run for 15 minutes, and it's going to look at how much time it has remaining and print out a funny image in the output, taking the maximum time. And you'll see the timer on the left is starting to accelerate now, so it's running at 700 times speed. Okay, to make this demo fun, this image is something you might recognize. So I'm waiting for someone to tell me where this image comes from. Oh, yes, Jens. Yes, it's Atlas Ruin. So the P2 plugin SDK, some of you in the audience have probably used it, has a command called Atlas Run. You use Atlas Run to boot up the Atlassian product and stick your plugin in it. Because you and I are very close together on the keyboard, sometimes you would try to Atlas Run and you would accidentally Atlas Ruin. So if you typed Atlas Ruin, you would get this Easter egg. You get a picture of Charlie, our old mascot, who is based on Atlas holding up the sky, and he would ruin the world by throwing it on the floor and breaking it in two. Now, if that's not entertainment, I don't know what is. All right, so it'll go through and do the rest of the picture, but you know you've seen enough. Yeah, what are we at now? Yeah, it's at 12 minutes, single invocation. This is now generally available. We made this available in GA last week, so it's now suitable for use in production. All you've got to do is add that timeout seconds declaration to your manifest, redeploy, boom, it's activated. You don't have to make any other changes. Although you might want to go and delete some of that crazy code that you wrote. Additionally, in order to monitor the time remaining, there's also a new function available on the app context API, which is also only available in the Node.js runtime. Invocation remaining time in millis that you can call to check to see how long we've got left to run your function. So you can actually, reliably know how long you've got left to run. All right, Ben, further enhancements. What else has the team been working on?
Thanks very much, Joe, for that riveting demo. Let's talk about some feature enhancements we made to triggers. So first up, we're talking about no egress web triggers, which is currently in EAP. So we've been making some changes to web triggers due to the announcement of runs on Atlassian. We made a tough decision the last month to exclude apps that actually use web triggers. It was actually presented today in some of the talks. Excluded from Atlassian eligibility. So since web triggers have no authentication by default, no restriction on usage, it's hard for us to justify how we can allow a Forge app using web triggers to not have any risk to customer data. So, however, we've built a new use case called input only use case, which will allow your web trigger to external party call into Forge web trigger, but return a very static message coming back. So no data can actually egress using this feature. If you actually use this, you can quantify for the runs on Atlassian eligibility badge. Now, how do you build this? So in AEP, we currently set up a new manifest section. So you go through a web trigger definition, you got security, egress, and then the key part is allow data egress equals false. So turn that on, we'll make sure that no data can go externally. Second key part we've built into this is allowed response. So you can set static messages and codes to respond back, and we'll take care of that for you. So in this example, you got status code 200, and the message is request successful. Or if you go negative key use case, you've got status code 500, and then message request failed. It's quite simple. In the code itself, when you define it, you literally respond with that message there. So if it's successful, status code 200, and then you stringify that message. Just be aware those messages have to exactly match between your manifest and your code. Otherwise, we'll strip it out and we'll not send anything back. This EAP is currently up and running. If you want to join, you can hit this URL, Node egress web trigger EAP, and we'll send it around after this talk. Also, future enhancements. We're very open to hear about your unique use cases and how we can potentially extend this capability further. So come talk to us or send us a message to the team. All right, let's jump into a 5-minute trigger schedule demo. So give me a second to just jump around.
I'm expecting this one to be 35 to 45% faster.
Oh, I pressed the wrong button. Oh. We're in?
Yeah.
Hack the mainframe. All right. So under scheduled triggers, we have a new interval. Get excited.
Can you zoom in at all?
Yeah, sure. Can't really see it. All right. Yeah. But if you've used scheduled triggers in the past, similar definition, you got a key, your definition of your scheduled trigger. You got a function, which points out to a function. And the interval now is called 5 minutes. So yeah, we've heard a lot of complaints in the past around hour being the lowest form, but now we have 5 minutes out in preview from today, so you can use it this week. Awesome. So bit of code. I run through this as a quick demo. Once again, we're using ASCII generators. We love ASCII in Compute World. This one will look at the time in Sydney, so try and work out if I was back home, if I'm asleep or awake right now. Shove it off to an ASCII generator and then punch it back out to Slack. All right, so very simply, as you can see here, we got messages coming down the pipe every 5 minutes. Another riveting demo from us. But you can use that right now. Hopefully you can use it this week and let us know if you've got any feedback. All right, let's go back to the demo. We're good?
Yep. Let's go through that. Yep.
Yeah, we're good. You're up.
All right. Last section, and we were right on time too. We're really good at this.
Yeah.
We're going to talk about what's next for Forge Compute. So when we launched Forge in 2019, we decided pretty early on to standardize on a functions as a service architecture. There's a great keynote from 2019 where Tim, who was on the keynote yesterday, and Joel, the product manager at the time, talked through why we made this decision. It had several benefits. The big one to me is it allows developers to focus on implementing user experience and business logic and not having to worry about so much boilerplate, right? Because the functions architecture, like you're working at a higher order of abstraction than like a service model or a container model. Additionally, because we're running on Lambda, scaling and cost, super dead simple. We could scale very easily from 0 all the way to thousands of concurrent invocations, basically without put any effort from us or any effort from you. So that was a big win. And then additionally, the deployment model, like the one-size-fits-all deployment model of Lambda, and the fact that deploying, you don't have any like overhead costs to just deploy and have it sit there, meant that we could kind of like have a really great experience where deployment was simple. You just deploy it up, it's ready to go. Trying to replicate that that golden moment of like building stuff in P2 plugins. And for the most part, these benefits have really borne out. I mean, like the boilerplate stuff, with 55-second functions, maybe not so much. But I think it's telling to see the success of this model by looking at the new partners who have entered the marketplace since 2019, who are kind of building successful Forge-only businesses. Which was kind of what we were trying to do, right? We're trying to like breathe some new energy into the marketplace in the cloud, try and explore a new way of building and rapidly prototyping new apps to solve problems for customers. But there have been some limitations with this approach. As I mentioned, some use cases just don't work well in a FAS model. You end up losing the simplicity benefit and you end up building something more complex and full of so much more plumbing than what you would have if you just kind of built something using a different architecture in the first place. Trying to work around the constraints of combining functions, storage rate limits, product REST API rate limits inside a single function, lots of complexity. The other big issue is the cost of rewriting, right? So we're well aware that we have lots of apps out there in Connect and Server and DC, and we're asking you all to move to Forge. And rewriting your app from Connect or DC onto an opinionated JS-only FAS, is, in the best case, quite time-consuming and maybe a bit expensive. In the worst case, it's just technically infeasible. So over the last few months, we've been exploring how we might address these problems. We want to give developers a way to build on Forge that is a little bit less restrictive, but still upholds the value proposition of the Forge platform that we tell to customers. So I'm excited to announce that we are shipping something new. Forge containers are coming. So this year we're prototyping a solution to run containerized code on Forge, and we're aiming to open up an early access prototype of Forge containers sometime in our 2026 financial year. And as a reminder, Australia is weird. Our financial year runs July to June. So FY 2026 is sometime between July this year and June next year. And please keep in mind that we're very early days on this project. Like the team back home in Sydney is literally doing Sprint Zero stuff right now. So this date is broadly indicative, right? Not necessarily a commitment. If I'm here at Atlas Camp next year and something has gone horribly wrong, I'm sorry. In terms of what to expect, there's a few key reasons why we think Forge containers are going to be compelling for you. Firstly, the containers are going to give us the capability to run a wider variety of workloads that are going to meet your needs better if you're doing anything super complicated. So things like long-lived services, batch operations that run for hours, fire and forget tasks, like once-off init tasks or migration tasks. We're planning to support all those kinds of workloads. Additionally, we're planning for the container runtime environment to be language agnostic, so we'll be able to bring additional languages into Forge beyond just JavaScript and TypeScript. And we're planning for containers to be modular, right? So there's a big limitation today with Forge that you have to build and deploy your app as a single monolithic unit. And if you have a large development team or a large suite of services running your app, deploying them as a single atomic unit kind of encourages some DevOps bad practice, worst practices, not good practices. So containers will be modular and deployable independently of the rest of the app. So you'll be able to kind of manage the lifecycle of the deployment and versioning of a container independently from other parts of your app. And finally, we're going to be giving you more control over resource allocation. So as the developer of the app, you'll have more control over the resource allocation and auto-scaling profile of the container, which will give you more levers to improve performance and control costs. In addition to these benefits, okay, that was the good news. Bad news time. There will be some constraints. So I think it's important to call out that while we're building a containerized solution, right, we're not AWS. They're over there in that booth. And we don't want to get into the business of building a general purpose FAS, right? We have to find the right balance between what enables you to build what you need without trying to like replicate everything that a PaaS would provide. So Forge containers is still somewhat opinionated, and there will be some things that you should be aware of. The first one is that our containers in Forge are going to be serverless and therefore stateless. So the platform will be in control of spinning up and spinning down containers as dictated by the needs of the platform. If you're familiar with serverless containers, this should not be surprising to you, but it means that you can't store any state in a container. Or you can, it just might disappear at any point in time. So if you have persistence needs, they need to be externalized into provided services like Forge SQL or entity properties, or if you're using Forge Remote, an external data store. Additionally, there may be image restrictions that we impose on the platform to ensure that we're upholding customer trust and security. So this could come in the form of things like Atlassian providing specific base images that you must inherit from. And additionally, we're also looking at things like image scanning and expecting containers to provide a bill of materials so that we can verify that containers are patched and secure, because you, the developer, will be responsible for what's inside the container. Finally, containers are going to have limited connectivity, right? So containers are still part of the broader Forge platform, and that means that they'll still be subject to the Forge egress permissions that we apply across Forge in order to meet customer expectations for runs on Atlassian and cloud apps. And that means we have to control the networking. So we're not going to be able to provide you a solution where you have full ability to define the attached network interfaces on the container, or be able to like configure custom VPCs or anything like that. Here's a concept of what this might look like. This is a very early design prototype that me, a PM, not an engineer, built. It's an illustrative mock-up of how containers will fit together within a Forge app. So this is not what the solution looks like. In this example, you can see we have a Forge app manifest, and we're declaring a container image in it. Now, this image could be built and deployed independently to a container registry, but in this example, we've provided a path to a Docker file. So when you run Forge deploy, we're going to find that Docker file, we're going to build the image, and we'll package it up, deploy it with your app, just to simplify how much is in the manifest right now. The container image is then referenced by a service declaration in the manifest, which is a way you might be able to define a service workload to run in your Forge app. And that's, where's my notes? You can configure auto-scaling and potentially also some other resource allocation directives directly in the app manifest for that service. And now the containers that you build and run in Forge, they're going to be able to do anything, right? If you want to put a Minecraft server inside your container, you can probably do that. If you want to run Bitcoin mining, actually, bad example. You'll be able to do it. You might not be able to connect to it, right? But what happens inside the container is your responsibility, and you can do anything you want within reason. But I think the exciting thing is that containers will be able to plug in to the rest of the Forge platform, right? So in this example, you can see we have a trigger module that's backed by an endpoint instead of a function. And that endpoint is declared as a reference to the container service with a relative URL path. So when that event trigger is invoked, we'll route that event handler to the specific HTTP path on your container service, right? And we'll apply that across the rest of the platform. So anywhere in Forge, you can declare a function or a remote. You'll also be able to provide a container implementation. We're still finalizing scope and requirements for Forge containers. We're very early in its life cycle, and the team's super excited to be working on this. So this is a great opportunity and time to share your requirements with us. Thank you to everyone who has already booked time with me to talk about it. I'm very happy to be talking to you. If you're interested, here's a link to a survey where you can kind of fill out some details about what you're looking for at a high level, and also a way for me to contact you. Otherwise, please look for me and Ben during the rest of the week. We're happy to have ad hoc conversations about containers. If all else fails, find me on LinkedIn, connect with me. Happy to set up some Zoom time to talk more. So what this means going forward is that Forge will have 2 supported environments for compute. We won't be replacing functions or deprecating it just because we're building a container solution. You'll be able to choose one or the other, or a mix of both, depending on your needs. So functions will remain as a capability that's ideal for developers who want to focus on functionality and leave the rest to Atlassian. Containers will be ideal for experienced developers who want to build their app as a suite of modular independent components, or if you just really hate JavaScript. Speaking of, okay, I mentioned we're going to make it language agnostic. We're planning to provide support for a variety of languages, but I deliberately have not said which languages because we haven't figured it out yet. So we're now going to do a quick poll to see which languages you care about. So I went to the Stack Overflow 2024 developer survey, and I went and looked at the top languages that developers are using, excluding things like HTML and CSS and Ant build files. And these are the top 4. So if you are interested in Java or other JVM languages, please raise your hand. All right.
Most of the room.
Yeah, that's about half the room. Nice. Okay. Python. Oh, wow. That's more than I was expecting. Yeah, maybe 25%, a quarter. What about if you don't care about other languages, you just want us to fix TypeScript in Forge? Yeah, okay, cool. About half. Nice. All right, and I was formerly a .NET developer, so please don't feel like you're being singled out by this question, but who's really looking for C# or .NET? Oh, I am. C#'s a great language.
We're not doing it.
Okay, let's quickly recap everything that we covered. So we've released the Node.js runtime. It's generally available. It's pretty much awesome in all ways, and everyone needs to adopt it by the end of February. If that is a problem for you, please find me before the end of this event so we can figure out what you need to do. Long-running functions is now available. It's in GA, suitable for production workloads. All you have to do is add a single declaration to your manifest and deploy. It's ready to go. We've done a bunch of cool enhancements to other triggers, 5-minute schedules, and no egress web triggers that are compatible with runs on Atlassian. If you have other use cases for web triggers and you haven't already spoken to Neil, who is the PM who is working on that, hi Neil, thank you very much for everything you did. Come and talk to me because we're going to consider doing other enhancements to find other ways to bring other use cases web triggers to runs on Atlassian. And then finally, containers. If you care about containers or you need containers, fill out that survey and or try and find some time with me and or just like hunt me down at home in Perth. We want to learn what you need so that we can make it good. Thank you.